friends, today we will see example regarding truss. So we will start from static structure. In static structure we will create one geometry. For creating geometry we are supposed to have some references. So for that we will take the help of one book. Here you can see one example. There is a one truss example is there. Problem is determine the forces in the truss shown in figure, which is subjected to horizontal and vertical loads. Mention the nature of the force in each case. So first of all we'll draw this geometry. You can see 4 meter widths are there and height is 1.5 meters. In this example you can see the width of 4 meter and height is 1.5 meter. So we'll generate this geometry in design modeler. First of all set unit our length in meter, so meter is appropriate. So start with XY plane, look at, go to sketching. In sketching if you have a grid then it will easy to generate truss structure. So go to grid, apply grid structure. Due to the length of each grid segment I will go at 1 meter. Easily one can snap it. So go to draw, create line. So our width is 4 meter. This is 4 meter and height is 1.5 meter. So 3 is there, 1.5 in between. So in between just. Likewise we will create other 3 triangle. Now apply the dimension. Now you can see 4 meter and for vertical dimension make 1.5. Now for geometry frame is ready. Now go to modeling. First of all off the grid. Now you can easily visualize your geometry. Let's compare with our geometrical work. 0.5444. Okay. Now next step is create this line body to part body. So go to concept, lines from sketches, create it, select the geometry, now select the sketch, apply, then generate. Now you can see the one line body has been created. Now you can see the cross section is required to apply. So for that we will go to concept again, go to cross section, then circular. You can give the radius of any kind. So I will give 0.02 meter.
સર મેં તમારી પાસેથી 2015નું કલેક્ટ કર્યું હતું.
Now we will go again line body. Now we will apply the cross section that we have created. Now you can see our line body has completed. If you want to visualize in 3-dimensional way, then go to view, in cross sectional solid. Now you can see the 3-dimensional truss. You can visualize. Actually this is a 2-dimensional, but it behaves 3-dimensionally. Now next step is go to model. In model you can directly update it from outside, but we will go in detail inside. So whatever you applied update by default, you can apply it by outside also. So we'll go inside and find different options. Now you can see the mesh. In meshing, now you can see 2-dimensional truss body. Now click on mesh, provide update. So whatever the default setting will be there, it will provide the mesh. Now you can see, if I want to increase the mesh density, go to relevance, apply 25%, then again update. Likewise you can increase your mesh density. For our case it is enough to solve our problem. Now we will apply the boundary condition. In that case, one end is fixed, another is the roller support. So select the point and go to support. Support provide the fixed support. Now next is the roller support. Again select the point, go to support, displacement. In roller support you know that y direction is fixed, in x direction provide the moment. So y direction is immediately fixed. Now next is the force. Let's see what type of forces are there. Now you can see 3 kN, 6 kN and 8 kN. 3 and 6 is downward, and 8 is the horizontal forces. So let's apply it. Select the point over here, go to load by the force. Here there is a two method, vector and component. So here we will see the component method. In component directly we can apply to XYZ positions. In our force is y direction 3 kN and it is a downward, so minus 3000 here there is a different force, so take other load and force, apply 6, but it is a minus. Go to component, y direction, minus 6000. Now next force is horizontal. Again go to force. Now here we will see the vector method. In vector method you are supposed to provide the one reference line. First of all provide the magnitude, which is 8000 Newton. Then for the direction select the link in which direction you are supposed to apply. So now you can see the boundary condition of truss system. One is fixed, here is the roller support, 3 forces are there. Here there is a magnitude with directions. Now we will solve it. Now solution has done. So first of all go to deformation. We will see evaluate. Now you can see deformation 1.35 mm. But here our intention of solving the problem is to find the reaction forces as well as forces in each link. So let's find it. First of all, reaction forces, go to probe in force reaction, select the fixed support. Now again go to probe, force reaction and select the displacement. Now for the forces in each link, go to beam result, axial force. Now evaluate. Now you will get the force reaction on roller and fixed support. In fixed support you can see the total reaction 8544. Now in x and y direction you can see 8000 and 3000, near about or 8 kN or 3 kN. Let's verify with the theoretical. Now you can see 8 kN and 3 kN is a reaction at A point, which is verified. Now in roller support you can see 6 kN is there. Now you can see it is near to 6 kN. Now our force reaction is verified with the theoretical. So your analysis is correct. Now let's verify with the axial forces in each link. In axial force, click on axial force. Now you can see different forces in each link. You can see the animation. Now for verification you can see the color coding. In color coding in form of you can verify in form of color coding, but it is difficult to exactly say the amount. So for that go to probe. Now click on each link. You can click on anywhere on the link, particular link. Reason is there is the same color on each link, so the same force has been generated. Now verify with the theoretical. You can see 11.984 near to 12, near to 5 and 5 kN. And 5. You can see it is verifiable. Likewise, all the reading has been verified. So our purpose of analysis is it must be verified with the theoretically. So it has verified all the result. So the main thing in analysis is it must be verified with practical or theoretical. So you can see it has been verified with the theoretically results. So for further information, please subscribe our channel, and so you will get the updated videos in each session, and in next session we will come with the different examples. Thank you.